Hello dear, in this video we are going to learn about the language of chemistry part 2 for the class 8 ICSE board. Let's go to the chapter. Concept of valency. The number of hydrogen atoms which combine directly or indirectly with one atom of an element so as to form the compound is called valency. Assumption in finding valency of elements. The valency of hydrogen and all metals is considered positive. The valency of all non-metals except hydrogen is considered negative. As the molecule of compound is electrically neutral, then it assumed that the total positive valency in its molecule is equal to total negative valency. Examples: in the compound HCl, one atom of hydrogen combines with one atom of chlorine, therefore valency of chlorine is -1. Similarly, in the compound H2S, two atoms of hydrogen combine with one atom of sulfur, therefore valency of sulfur is -2. However, this method of calculating valency is outdated and has been replaced by atomic model. Variable valency. It has been found that certain metals exhibit more than one valency. In such a situation, metals are said to exhibit variable valency. The reason for variable valency in certain metals is that depending upon the experimental conditions, an atom of the metal loses more electrons than are present in its outermost shell, that is, valency shell. It loses some electrons from the shell next to outermost shell. Thus, it exhibits variable valency. For example, an atom of iron has 2 electrons in the valency shell. On losing these electrons, it has valency 2+. However, sometimes it manages to lose one more electron from its inner shell and hence its valency has 3+. How to name element with two different valencies? If an element exhibits two different positive valencies, then suffix OUS is attached at the end of the name of the element for lower valency, and suffix ICE is attached to the end of the name of the element for higher valency. Example: iron. The Latin name of iron is ferrum. It exhibits two valencies, that is 2+ and 3+. The lower valency of iron 2+ is named as ferrous, and the higher valency of iron 3+ is named as ferric. Next one, radical. A group of atoms, that is having some negative or positive charges on them, which can retain its identity in series of chemical reaction, is called radical. Examples: ammonium is a radical having formula NH4 the whole plus, and the carbonate is the radical having the formula CO3 and the whole 2 minus. How to write the chemical formula of compound? We have 3 steps for writing the chemical formula of the compound. One of the most important points to remember while writing the formula of a chemical compound is that it always electrically neutral. That is, the compound should be always electrically neutral. It is very important. In other words, the positive and negative valencies of the ions or radicals present in the chemical compound add up to 0. To write the formula, we have to follow the 3 steps. These steps, that is, this method is called crisscross method. The first step: write the symbol of the positive ion or the radical to the left and the negative ion or the radical to the right. We have to write the symbol. Then step 2, put the valency numbers of each of the radical or ion on its top right. Then divide the valency numbers by the highest common factor, that is ICSE, if any, to get symbol ratio. Now ignore the positive and negative symbols. Then interchange the valency numbers of the radicals. Then step 3. Shift the valency numbers to the lower right of the ion or the radical. If the radical receives the number more than 1, then enclose it within the brackets. Do not enclose single atom within brackets. Naming chemical compounds from their formula. Usually, the elements present in a compound are named in order of symbols appearing in the formula. Some rules are applied in the naming of compound. We can see all the rules one by one. So first rule, if a compound contains only two elements, that is binary compound, one is metal and the another one is non-metal. So we have to write the metal in the first and give the suffix of IDE for the non-metallic part. We have to write the non-metallic part in the second part. For example, compound of sodium and chlorine is sodium chloride, that is NaCl. Here sodium is the metal and chlorine is non-metal. So we have to add the sodium first and we have to add the suffix IDE at chlorine. So that is called sodium chloride. Like the same, the compound of magnesium and nitrogen is magnesium nitride. Compound of aluminum and oxygen is aluminum oxide, Al2O3, and the compound of calcium and sulfur is calcium sulfide. Second rule, the compound containing two non-metals are named by using Greek prefix like mono, di, tri, tetra, penta, which denotes the number of atoms present in the compound. For example, CO stands for carbon monoxide. Here, the atom for oxygen is 1, so the Greek prefix is mono, so monoxide. Then CO2, 2 for the Greek prefix for 2 is di, so carbon dioxide. Next NO2, 2 stands for di and the symbol NO2 is nitrogen dioxide. Then SO3, that is sulfur trioxide, tri for the suffix of Greek suffix for 3. Okay. Third rule, compounds containing 3 elements, that is tertiary compounds, one of which is oxygen, are named with the suffix ate, 8 at the end, provided there is only one such compound. If there is two compounds, the one with more oxygen is named with the suffix ate end and one with less oxygen is named there with the ite ending. Fourth rule, in a compound, oxygen is less than the oxygen present in the compound ending with ite, then it is given the prefix hypo in the beginning. Like the same, if oxygen present in the compound ending with ate is more, then it is given the prefix per in the beginning. Examples, in KClO is named for potassium hypochlorite as it contains less oxygen than potassium chloride, KClO2. KClO4 is named potassium perchlorate as it contains more oxygen than potassium chlorate, that is KClO3. Naming of acids. The names of binary acids, that is the acid containing hydrogen and one more element, are given by adding prefix hydro and suffix ic to the name of the second element. Examples, acid of hydrogen and chlorine is HCl, that is hydrochloric. Hydro is the prefix and ic is the suffix of this chlorine acid. Acid of hydrogen and fluorine is HF, that is hydrofluoric acid. Here hydro is the prefix and ic is the suffix. The names of the acid containing radicals or polyatomic groups are given on the basis of second element, but prefix hydro is not used. Examples, H2SO4 is the sulfuric acid. Then H2CO3 is carbonic acid. H2SO3 is sulfurous acid. OUS is used because of less number of oxygen atoms. Next topic is naming of bases. Bases containing OH radical are named as hydroxide after the name of metal. Examples: NaOH is sodium hydroxide. NH4OH is ammonium hydroxide. Trivial names are common names. There are certain names of compounds which do not follow any systematic rule. Such names are called trivial names or common names. Chemists have not considered wise to replace these names by systematic names as they are widely understood by the common man. Examples: common name for nitrogen trihydride is ammonia, that is NH3. Then the common name for sodium chloride is table salt, NaCl. And the common name for hydrogen hydroxide is water, H2O.